So today we will look at the topic in chemistry, and that is bonding. You can call it bonding or you call it chemical combination. So what does bonding means? What does it entails? What is it talking about? So we have the idea that atoms are very small, though they consist of three more subparticles. So quickly, I will have to explain atomic structure. Atomic structure. Atom is actually very small, but we have the complexity in atoms. So even within atoms, we have the ones that have smaller sizes, we have the ones that are bigger sizes. So the structure of atoms shows that the atom has a center, and this center is called nucleus. Meanwhile, around it you have space of different energy level, or you call it shell. So which continues till infinity, but let's just look at just one of it. So which is the one that is closer to the nucleus? Okay, so now this is the nucleus, and the nucleus is the center consisting of two particles that are smaller than even atom itself, and that is proton with neutron. So having this, there is a third particle which moves around the nucleus. So that will be electrons. Electron. Now, these three particles have their characteristics. This one, which is electron, has no mass but has the charge of -1. Nucleus has no charge but the mass of 1. This is the mass. Then, neutron has the mass of 1 but no charge. While proton has the mass of 1 and the charge of +1. So these are their properties. Now the main one that determines the chemical property is proton, because no atom of any element will have the same number of protons. So protons is what we use to differentiate atoms from each other. So the number of proton can never be the same in every atom. Okay, so having this, atom with the smallest number of proton is hydrogen, having just one proton. So the next atom, which is bigger than hydrogen, is helium, having two protons. So then the proton and neutron does not have a specific arrangement in the nucleus. They are just packed together. Meanwhile, electron has specific arrangement or distribution, or which you can call electronic configuration, around the nucleus. That is when the number of electrons increase. So what determines the number of electrons outside the nucleus is the number of proton inside. So which means number of proton is the same as number of electron. That is for a neutral atom. What do I mean by a neutral atom? Take for instance hydrogen. Having one proton here, hydrogen has no neutron. So which means in the nucleus of hydrogen we have only proton and then one electron out. So that causes a charge balance, because the charge on proton is +1 and the charge on electron is -1. So of which the sum of the two will give us 0. So which means the atom is a neutral atom. So that is the way it will be for bigger atoms having more than one proton and more than one electron. Okay? And such bigger atom will also have more than one neutrons. So the number of proton increases as we move from the smallest atom to the bigger one. Just like atoms comes from different elements. So the atom of hydrogen is atom of element hydrogen. So we have other elements and their atoms. So the atoms are bigger than each other, but hydrogen has the smallest atom. So when you move away from hydrogen to other atoms, the complexity, which is the number of proton and electron and proton and neutron, begin to increase. So that shows the size of atom increases. So now, if we have the proton 5 in the nucleus, so definitely there would be 5 electrons outside the nucleus. And these 5 electrons will be distributed not in this first shell, because there are rules. I will still make a class where we explain in details what atomic structure and the distribution of electrons seems to look like in details. But here we're going to discuss bonding. So we just need a little idea of this to understand bonding. Now, take for instance, atom like boron. Atom from boron element has 5 proton. Then it has also definitely 5 electron. So now the number of neutron could be 5 neutron, and number of neutrons, since it doesn't contribute to the charge, it could change. So we can have boron atom with number of neutron 5, and we can have boron atom with number of neutron 6 or 4. Okay, those that exist is the number of neutron to be 5 or to be 4. So which means we'll be having boron 10 and boron 9. So this number I write up here represents the sum of the number of proton plus neutron, so which we call the mass number. So it shows that in this boron atom you have 10 proton, 10 neutron. In this you have in this boron you have 5 proton, 5 neutron. So here you have 5 proton and 4 neutron. Don't forget the number of proton cannot change because that determines the property, the chemical property of the compound. So for me to call this boron, it must have 5 proton. So the only thing I could change is the number of neutrons. Okay, so and this phenomena whereby atom of the same element has the same atomic number. Reason what I call atomic number is the number of protons. So I'll write that down here. So which means the number of proton does not change, but the mass number, which is the sum of the number of proton and neutron, are different due to what? The different number of neutrons in each atom. So this phenomena is called isotopy. Isotopy is a phenomenon whereby atom of the same element, like boron to boron, has the same number of proton, which is atomic number, but have different mass number, and this is due to what? Different number of neutron present. So now the number of proton and neutron added together is mass number, so they all be at the nucleus. Meanwhile, electron is distributed. So now the manner of distribution of electron is in such a way that, take for instance in boron, we have more complex atom, but in order to dive quickly into bonding, we just have to explain this first. So the shell that is closer to the nucleus has lower energy and lower space, so it can only contain 2 electrons. So we distribute the electrons this way. So then we have 3 more electrons, so we have the 3 electrons feel outside the first shell. So that shows that we have 3 electrons outside. So this outside electron is only capable to take 8 electrons, so which means boron needed 5 more to complete this shell. And then we have other shells after this second shell. So others too will also take maximum of 8 electrons according to octet rule. So this is the basic of understanding bonding. Now the affinity, or let's say the satisfaction of every atom, is to complete its shell to be 8. And if the atom, just like hydrogen, is making use of just a single shell, is the aim or the utmost satisfaction of hydrogen is to get the configuration whereby two electrons is complete in its shell. So this is the reason why atoms go ahead to bond with each other. So that brings about bonding. When atom is trying to bond with each other, they are trying to make up the bond, to complete the electrons in their outermost shell. What do I mean by outermost shell? This shell is inside, so this is the outermost. So if this particular atom want to complete its shell, it has to go for a bonding process. That is combining with atoms that is different from boron in order to ensure that it's made up with the configuration, which is octet configuration. Octet means 8 configuration. So octet configuration is common to every other shell apart from the first shell that takes 2, which is duplet configuration. So the purpose of bonding is just to make sure that the bond in atoms, I mean the electrons in the outermost shell of atom, is completely in its required configuration. So now, since boron does not have any other means to complete its configuration, it will then form a bond. So now you'll be asking yourself a question: that what of electrons that has 4 electrons in the outermost shell, 2 electrons in the outermost shell, and 1 electron, and so on, or 7 electrons? Will they form the same kind of bond? No. So that is why we have different kind of bonds. So the bonds we have now depends on the bonds any atom is going to form depends on the number of electrons it has in its outermost shell. So when an atom has 3 electrons in the outermost shell and needed 5 more, so there is still more affinity, like you still need you needed more than what you have already. So in the outermost shell you have 3 and you needed 5, so you can go extra mile to get the 5. So that determines the type of bond you form. And there is a case of, let's say, chlorine. Chlorine has a 2. We have to write this configuration in this form. So these 2 in the shell represent this. Then I will put the 3 like this. So then for chlorine, the first shell is filled with 2. The second shell is filled with 8. So chlorine is actually using the third shell, and it contains 7 electrons. So which means chlorine is just ready to get one more bond, and that is very, very close to octet configuration. So chlorine will be very, very reactive to get this bond. So it will prefer to bond with something like boron. So how does that happen? We dive into what we call the type of bonds. So let me get rid of this, so we now talk about the type of bonds. Okay, there are only 3 types of bonds that exist between atoms. However, we have bonds or forces that exist between molecules. That will be a story for another day. So we want to talk about the bond that exists between atoms. So this bond could be ionic bond, and it could be covalent bond. So these are the 2 major types of bond. Then the third one is just like covalent, but is a special case of covalent bond, so we call that dative bond. So these are the 3 type of bond that atoms normally form. So now, what is the criteria for forming any of these bonds? It depends on the electrons in the outermost shell, which we call the electronic configuration. So now let us talk about ionic bond firstly. Ionic bond is a type of bond that takes place between a metal and a non-metal in such a way that the metal has to lose all its electrons so that the non-metal accepts it, and then they form 2 opposite charges which then attract each other, and then they get bonded together. How do you identify a metal that would love to form ionic bond? any atom that has one electron in the outermost shell, two electrons, or three are metals, so they tend to lose all their electrons. So those that has four electrons in the outermost shell will never want to lose electron. So all they need to do is to go for covalent bonds. Then those that accept the electrons are those that has like six electrons in the outermost shell, or they have seven electrons in the outermost shell. Those are mostly the atoms that accept the electrons. So I will make an example with sodium. Sodium has the configuration of 2, 8, and then one electron in the outermost shell. So this is first shell filled up, second shell filled up, and this is the third shell. So sodium is actually needing just 7 electrons left to complete its configuration. So then if this is sodium Na and we have chlorine to be 2, 8, okay, and having 7 electrons in the outermost shell, okay. Now this needs 7 more, why this needs 1 more, so this is Cl. Then this is so desperate, like it could lose its electron down to chlorine. Immediately that happens, I told you that the number of proton must be equals to number of electrons so that the charge could be 0. But in this case now, don't forget that we have 11 electrons all together in sodium. So that implies that sodium, we have 11 proton. So which will balance the 11 electrons here. So after losing one of the electrons, the proton is going to be 11, and then the electron outside is going to be 10. So which means you'll be having minus 10 plus 11, and that will give you plus 1. So sodium will no longer be an atom, it will form a positive charge, okay, by losing electron. So if you have to write an equation for that, we write it as Na in its neutral state loses an electron to form this, so the electron goes. Now chlorine has 17 electrons altogether with the inner shells, so which means chlorine atom has 17 protons, so which must be equal to the number of electrons. So now if chlorine accepts this electron, then it becomes a negative charge, because the number of electrons will now be greater than proton. So the number of electrons would be 18 minus. So if you add to this, it's going to become negative ion. So this charge form of the atoms are not called atoms, they are called ions. So that is why the bond sound ionic bonds. So then the chlorine, okay, you know that we cannot find chlorine atom in a single state like this, so it has to be this. So we have to balance the equation so that we could have 2 electrons. So each chlorine atom is accepting 1 electron, so we have 2 electrons here, and then you have 2Cl minus. So the 2Cl minus is going to be attracted to Na plus, 2Na plus, so you'll be having 2Na plus with 2Cl minus. So they will eventually form 2NaCl. So if we're going to draw that in the structural form, so we are going to put the sodium 2,8. So the number of charge electrons that bonds them is this. So we have 2,8. Oh, sorry. So we can see it now. So then you have this. So the electrons here will move all around the bond as if it is a single shell. So which means the number of octet configuration 1, 2, 3, 4, 5, 6, 7, 8 will be applicable for both, and this compound will be stable. So we would have to continue covalent and dative bond in the next class. So we can have this type of bond in aluminium oxide also. Aluminium oxide. So we would be using some videos to explain how the bond exists in ionic bond exists in aluminium chloride when we get a class. So in that wise, we just have to stop here, and then we explain with more examples of compound that contains ionic bond. Then we continue with covalent and dative bond in the next class.